So we are pleased to have you, Lisa, with us. Thanks so much. And now, if you would tell us about water quality, please.
Awesome. Thank you so much, Mike. Well, I'm really glad to be here, everyone. Thank you for the invitation, and I look forward to speaking with you about this topic. If at any point y'all have questions that come up about water quality, I'm here with LCRA, willing and able to help. So we cover a lot of topics in this talk, but there are many more that we handle in our department. So you can always feel free to reach out to us and me specifically with more questions regarding water quality. So to kick us off, make sure my slides are progressing here. There we go. So these are my daughters, and I have a long history of love of native plants in my family. Whenever I was a little girl, I grew up barefoot in the country, and my best friends were wildflowers because my brothers were not as fun as wildflowers. So I have, if y'all can see this, this is a book that I got whenever I was a kid. It is falling apart now, but it's the Wildflowers of Texas book, and was my companion through many fields and forests as a kid in the Blackland Prairie of Northeast Texas. So my daughters are carrying on the tradition and have a sincere love of native plants as well. My uncle is also a accomplished wildflower photographer, and I'll share some of his photos as well. So I want to first off start with kind of a broad overview of the Colorado River Basin, and then we'll go into the Highland Lakes region a little bit more specifically. So let's start out with the definition. And you don't have to chat this or anything. I just want to kind of get your brain thinking on this background knowledge here, because I'll use these terms a lot in the presentation. So what is a basin, also known as a water catchment or a watershed? Is it A, the surface area of a lake, B, the area of land that drains to a common point, or C, an arbitrary political line drawn on maps? I may not have given you enough time, but for sake of moving forward, a watershed, which it commonly is referred to in just the public, is an area of land that drains to a common point. Something that we in the water resources area like to refer to it more as is a water catchment area or a basin, because a watershed kind of implies that that water needs to leave and be shed from the land. But in reality, we want that water to soak in, slow down, and become a part of the landscape, as opposed to flowing just directly to those creeks and streams where it readily flows quickly into our larger rivers and then the ocean. So it's lost if it doesn't soak in for the most part. Here's a diagram kind of displaying that. So you'll see the white dotted line along this area called the watershed divide. And it doesn't have to be, a mountain to be a watershed divide. Every piece of land is in a water catchment area. And the higher points of land typically are at these watershed divides, right? So you'll have this specific part of land where you could straddle the watershed divide theoretically, where a drop of rain goes on one side of you, it will flow into another river basin theoretically, and on the other side will flow to another river basin or major watershed in Texas. So another point is all these tributaries, it's kind of like veins in our bodies, really, or if you look at a leaf vein, it all kind of travels back to that petiole or that stem in that same similar point, right? So going back to our definition, that's what we're looking at here is a water catchment area. So what this map is showing is the natural regions of Texas. And you can see those here in the little color-coded legend, the different regions. The black lines represent the major river basins of Texas. And here is the Colorado River Basin. So you can see it's a large chunk of our state. It's about 900 miles of the main stem river between the headwaters in Dawson County and its mouth at Matagorda Bay. There's a small little section of the watershed or basin in New Mexico, but for the most part, we kind of say it's entirely within Texas. It's approximately 42,000 square miles, makes up approximately 16% of Texas, and the topography is really varied with elevation changes from nearly 3,000 feet in the upper watershed in West Texas, all the way down to, of course, sea level at the mouth of Matagorda Bay. So that's that common point, right, where the water flows in our basin. It goes to Matagorda Bay, and then, of course, eventually to the Gulf of Mexico. So you can see that the water basin really slices through the majority of these major natural regions. And this brings a variety of native organisms that occupy this section of Texas because of it. So we have over 70 fish species, over 80 species of aquatic insects, at least 22 species of native freshwater mussels, which you see in the middle portion of this slide, including 4 rare native freshwater mussels that I do a lot of my work on to protect and conserve. We're also seeing a resurgence of alligator, beaver, and even river otters in the river between Austin and Bay City. And I hear they may even be in the Hill Country. I just don't hear as many accounts of them in that area. So groundwater resources. So what we just spoke about was kind of the surface water, right? So the water catchment being the land on the surface, where when a raindrop falls, it goes to a certain spot. But groundwater resources are equally diverse, if not even more, and certainly less understood by the public because of the nature that it's underwater. So this is a map of the major aquifers of Texas. And if I click, sorry, it's a little clunky with clicking on this thing. So you'll see the Colorado River Basin overlay on this as well. And it, again, slices through a great variety of underground water resources here. So the flow dynamics are still being studied. There's a lot of interconnectivity between subsurface flow or groundwater and springs that feed the surface water. So just a very general overview on groundwater. There are people that know tremendous amount more than I do on this, but it's certainly an area where a lot more research is being done. And dye tracing studies, for instance, are so fascinating to see where a drop of dye goes in and know where it comes out. Very cool science. And the diversity of species for the aquifer systems is something that I can't even really do any justice to here either. There's a tremendous diversity, new species being discovered all the time in these aquifer species in our state. So one thing, just kind of one additional point about groundwater and its surface water connection is in these systems, in these rivers, creeks, and even lakes, we have a gaining or a losing situation that occurs. And this changes throughout the year or the particular waterway that we're talking about. But so a gaining section or stream is one that gains water from inflow of groundwater through the stream bed. So you'll see the arrows pointing up. The water table is kind of feeding that base flow of the river. A losing stream is what it says. Therefore, it's losing water to groundwater by outflow to below the stream bed. And sometimes these can be really dramatic recharge features. I'm sure many, if not all of you, have been to the Lady Bird Johnson Wildflower Center. They have some really cool caves there. Those are recharge features that go directly into the aquifer. But those recharge features can also be in the waterway. And that can look like whirlpools whenever the stream is flowing, just some really, really cool stuff that you can find with these recharge features. And one creek can be both gaining and losing depending upon where you are. So very fascinating. So this map provides an overview of kind of the sub-basins within our watershed. These little polygons represent the areas of the major tributaries to the Colorado River. And this area right here is, of course, where we'll be focusing today in the Highland Lakes region. So you can see the major tributaries are the Llano River, which is a very large watershed or basin, the Pedernales River, and then also the San Saba River, which is above Lake Buchanan, but certainly contributes a great deal of water and beauty to our basin. Okay, so first, like I said, we're going to talk about the Highland Lakes themselves, and then we'll talk about what water quality actually means. There are 6 dams that form 6 Highland Lakes: Buchanan, Inks, LBJ, Marble Falls, Travis, and Austin. Starting in the mid-1930s with Lake Buchanan, LCRA constructed these reservoirs to help manage floods and droughts and produce electricity for the region. The Lakes Buchanan and Travis are the only true water supply reservoirs that can hold and store floodwaters. But all of these lakes provide a diversity of uses and resources and are treasured for their recreational value, certainly. Okay, so overview of the Highland Lakes done. Most of you probably knew that, but now let's talk a little bit about water quality before we go into the specifics on the Highland Lakes and what we do within them to measure this. So water quality is really determined, it can be defined in a number of ways, but the primary characteristics that are considered at a broad scale are the physical, chemical, and biological properties of the waterway. So for instance, physical properties of water quality include temperature and water clarity. Chemical properties include pH, dissolved oxygen, and nutrients. Biological indicators can be algae, freshwater mussels, diversity of larval insects hiding under rocks, or variety and abundance of fish, for example. This is a list of programs and initiatives, not even an exhaustive list actually, within my department at the LCRA Water Quality Protection Group. This is just to give you an idea of the breadth of work that we do. I'm not going to go into all of these certainly today, but just kind of a list to show you what we're up to, plus others that I did not include. The orange bullets are programs that are carried out in the Highland Lakes region. I'll only be talking about a few of these programs today as mentioned, but like I said at the beginning, if you ever have questions about any of this stuff, we're here. So first, I'm going to talk about this Clean Rivers program. This is a program near and dear to my heart, as they all are, but I work very specifically in this program currently. We monitor professional monitoring of, and when I say professional, it means that we have staff trained in-house, very high quality assurance of the data, and that data is submitted to TCEQ, the Texas Commission on Environmental Quality, and it's assessed to be a part of the Clean Water Act ultimately. It goes up to the EPA for a review and kind of gives us a report card of what the water in our basin looks like to meet that swimmable, drinkable, all of that the Clean Water Act specifies. So we monitor roughly 70 sites. That changes from year to year depending upon the needs. But for the most part, we've had the same routine monitoring sites since the early 80s as a part of this program. So a very robust water quality data set. And you'll see here I listed out just a very small list of the total amount of things that we collect, but bacteria, dissolved oxygen, conductivity, nutrients. You can see any of this data at any time at waterquality.lcra.org. If you click on these little raindrop looking things here, you'll see data that you can pull up and download for each site. Sometimes there is a lag in the most recent water quality data because it has to be approved by TCEQ before it's posted here, but this is a great resource for those kind of getting real nerdy into the water quality data and want to look and see what historic data has been collected or certain parameters. In addition, the Clean Rivers program produces these annual basin water quality reports. And the topics kind of vary from year to year, but overall, it's details on water quality impairments, and impairments being what the report card says from TCQ and EPA on what our water quality looks like. Also data summaries and the activities that we've conducted related to water quality protection. And finally, as a part of the Clean Rivers program, I just wanted to state that we do have this public outreach component. It's comprised of local stakeholders just like you who show an interest in water quality and want to stay more involved. When we were meeting in person, this is kind of what those groups looked like. I miss all these folks, seeing them face to face, but we did a virtual program last year, and we'll be doing that again this year, probably in the end of the summer. We haven't set the date yet, but we'll be having at least one of these water quality advisory committee meetings in the coming months. And if you're interested in participating in that, kind of signing up as a committee member, it's very informal, but certainly I will add you to the email list and let you know when we have these meetings. Topics of interest are encouraged by all stakeholders. So the next program I'll mention is the Colorado River Watch Network. And I bet there are a few of you that certainly have heard of the program and maybe have even volunteered as a part of this program. So thank you if you're here, and please put in the chat that I can see later that you're here. We show so much gratitude to these volunteers who dedicate, a good chunk of time to monitoring water quality throughout throughout this watershed. So the CRWN program, as we refer to it, CRWN CRWN, is a volunteer water quality monitoring program, as you might have guessed. Currently, we have roughly 80 certified monitors or volunteers at approximately 100 sites throughout the basin. CRWN creates this early warning system that alerts LCRA and TCQ to potential water quality threats that are happening. I have a lot of examples of CRWN volunteers jumping up and saying like, hey, I've seen a change in water quality. What are we going to do about this? And then we can address that through the data, which is very powerful. This program encourages and supports community-based stewardship. I will say that this program is very popular and very full, and we only have one coordinator who's working on this in this program. So if you're interested in this, certainly reach out, but I will just be realistic with you here and say that it may be a while before you would be able to get an assignment for doing the water quality monitoring and training as well. We take training seriously, so. Here is a list of some of the indicators, or also known as parameters, that we collect as a part of the CRWN program. Two of note that I really wanted to point out that we'll kind of touch on a little bit later are nitrate, nitrogen, and E. coli. So nitrate, nitrogen is found in fertilizers, or really most organic matter. And then E. coli is the bacteria that we use as an indicator species to see if other more harmful bacteria may be present. So this picture right here is an old one, but I love it so much. This is Elizabeth Welsh, who was a long-term, the lady here in the middle is a long-term CRWN volunteer and also worked for the Austin Youth River Watch and just did a tremendous amount of great work with the youth in the Austin area. And the Austin Youth River Watch, if you don't know about that nonprofit, they work with local youth to conduct water quality monitoring in the Austin area and submit it to our program. Here is a interactive map, screenshot of the interactive map, I should say, of the CRWN water quality monitoring sites. So if you go to, let's see, where did my little, it doesn't, there it goes, it popped up. The crwn.lcra.org website, you'll see this interactive map here. And again, you can click on these and you'll see all the volunteer data from the beginning of CRWN history on here and can kind of play around. Okay, so I want to transition a little bit here with a segue from our water quality monitoring program to a new program that we've unfortunately had to really resource up this year. and this is harmful algae monitoring. So I want to give a little bit of background, not go into this too much here. I know this is a hot topic right now, but I want to give you some background and then segue into what I'm here to talk to you about in detail, which is the role that native plants have in protecting water quality and helping prevent this harmful algae proliferation from being as big of an issue in the future, hopefully, especially as more development occurs. So let's first start out by kind of defining algae. So what is it? The first thing to note is that most algae is actually harmless. Algae is an important part of the aquatic ecosystem. It provides food and habitat for microscopic organisms all the way to fish and mammals living in the water. Algae also produce oxygen through photosynthesis, just like land plants. In order to grow, they need light, water, and nutrients, such as nitrogen and phosphorus. You'll hear that word again, those words again. However, some algae can produce toxins that can be dangerous to humans and animals, and that's what I'm going to talk about here a little bit in this section of the presentation. So in freshwater, harmful algae is most commonly referring to blue-green algae, which is also known as cyanobacteria. The word algae is a bit of a misnomer for cyanobacteria because they're, in fact, bacteria, but it's often lumped into this algae category because it functions similar to other types of algae. So a cool fact is that blue-green algae are believed to be billions and billions of years old, some of the earliest organisms living on Earth. So for simplicity's sake for the public, we're calling this blue-green algae and not cyanobacteria, but you may hear it referred to as both. Blue-green algae can produce toxins. Not all of them do. I'll explain a little bit about those toxins here in a bit. You can't tell by looking at a patch of algae whether it's producing toxins or not, and scientific testing is required for that. So in general, there are two different types of growth forms or broad categories of harmful algae. The first is that I'll talk about is planktonic. So these are free-floating microscopic cells dispersed throughout the water. This is what people have typically thought of when they hear the term harmful algae bloom. These planktonic blooms typically are comprised of only a small number of species, and sometimes only one very dominant toxin-producing species. The tiny microscopic cells make the water turbid and typically very green. An example of a lake that has a lot of challenges with planktonic harmful algae blooms is Lake Erie, which is in Ohio and Michigan. But that's not really the type of growth form of toxic algae we've seen this year. A newer area of focus in the harmful algae research community is benthic algae. And this is different growth. This is a different growth form, I should say, than planktonic harmful algae. Benthic algae starts out its life on the bottom of the lake in areas where it can get what it needs to grow. So namely, enough light and enough nutrients. Again, nitrogen and phosphorus being those nutrients. That harmful algae or that algae mat that grows on the bottom can then float up to the surface and be, living in mats or even dead, just floating around in mats and globs on the surface. So this is the type of algae producing toxins in Ladybird Lake, or in the past. I think still they're getting that data saying that it's still in there, and was first detected in 2019 in Ladybird Lake, the first, really first account documented in our basin for harmful algae, or in our lower basin, certainly. So Lake Travis and Lake Belton also had the same type of algae starting February onwards. I'm not going to go too much into this. This is a little bit technical slide, but in general, there's four main groups of harmful algae toxins. That's anatoxin, cylindrospermopsin, microcystin, and saxitoxin. The primary toxin that we're dealing with in the Highland Lakes this year and that we're monitoring closely is this kind of new kid on the street, dihydroanatoxin. It's something that's pretty understudied. There's not a lot of science that's been done on this particular variant, and it is related to or called a congener of anatoxin A, which is why I have this red highlighted portion of dihydroanatoxin there. But again, it's a little bit trickier to detect because the science hasn't caught up with detection of it, and we had to find a specific lab that would be able to find it. So it's been an interesting last few months with this issue. The images here on the right are the ones I took from the Lake Travis algae samples. You'll see on the top are these little filaments that you probably can't see the length, but like 6 microns is super tiny, right? So these little guys are itty bitty and very high magnification here. In the bottom part, it's a zoomed out magnification, and these same little filaments are the teeny tiny sticks in the background. The larger glob of like brown, green branch stuff at the bottom is a green algae. So just the difference in size there is really interesting. The blue-green algae is interspersed in a lot of different types of algae we were finding, which is something kind of unique about what we were finding this year. So I want to talk specifics for just a minute. We're almost through with this harmful algae topic, but this is a picture of the most toxic site we have found in the last 2 months, which is Lake Travis at Travis Landing. It's at the lower end of Lake Travis on the east side of Hudson Bend. It was really surprising to us that this is what a toxic algae bloom showed up as. This would not have been considered suspect to us prior to February of this year. These brown globs are dominated by diatoms, which is a type of algae that dominates in clean, cool waters and doesn't produce toxins. However, what we learned this year is that those blue-green algae filaments that I just showed you of a toxin-producing species can co-occur with these other types of harmless algae and cause enough toxicity that they can kill a dog if ingested. And that is what happened, as we saw reports of a dog death and illnesses, and that's what prompted us to really dig into this. So before February of this year, peak growing season was thought to be in the warm summer months when it's more competitive in the water. This blue-green algae is more competitive, but we learned this year that perhaps that's something that's not always going to hold true. So we're increasing our monitoring to year-round, as well as the city of Austin, and trying to get a better hold on what's going on here. So we're really messaging, any time of year, you just have to be aware of this algae in the water and take precautions. This sign to the right here is an image the city of Austin produced. And I plunked it in here just to show, what they were displaying, which is what the science told us in summer and fall. It's this yellow, red, high risk season. But we're certainly changing our messaging since February, when, as mentioned, a dog died and was reported to us because the vet told us that it would, or told that dog owner that it was likely due to cyanotoxins. Later we later learned that there was another dog that was playing in the lake across from Travis Landing and had also died earlier on. But we found out about this in late February and have been working very hard ever since. I don't want to spend too long on this, but really just wanted to point out that the hot spot for toxicity was at the lower end of Lake Travis, as mentioned. And the toxicity is largely in the algae itself. It's not in the water. And we've been keeping close track on this at our representative locations. We're not seeing toxins in the water. It's contained within the algae. At all of our monitoring locations where we've looked at algae and analyzed it, we've seen potentially toxin-producing blue-green algae species in those algae chunks. So that's why we're saying, even if it's not producing toxins at that time, the potential for toxin production is there, and we're getting more science to really understand what's going on. We actually had to reach across the world to New Zealand to get better scientific understanding of this, because like we said, there's not a lot of research being done on both benthic algae blooms. As mentioned, phytoplanktonic are more common, right, and studied more. And then also this dihydroanatoxin is this newer area of research. So it's been really interesting. I think I've said that a lot. You can tell I've spent a lot of time on this lately. So last little thing I'll say here on this is we have a very thorough website with information, updates on what we've found, ways to minimize exposure to it. And then what I'll talk about kind of segueing into this is tips to minimizing the growth of algae. Also, these are some signs that we produced. If y'all live along the lakeshore property and maybe have an HOA park with access to the lake, these are PDFs that you can download from that LCRA.org/algae site and post and put up as you'd like. So this leads me to where you come in. What can you do to help protect the creeks, rivers, and lakes of this region, especially amidst a huge boom in development happening right now in Central Texas? And with this, kind of challenging issue we're facing with harmful algae, keeping people on their toes a little bit. So at LCRA, we have some strong regulatory protections and for water quality, I should say, in place. These being the Highland Lakes Watershed Ordinance. This is a program where LCRA actively manages water runoff from around the Highland Lakes to contain the pollution found in stormwater runoff, such as pesticides, soil, nutrients, and other contaminants that need to stay out of waterways. We have an on-site sewage facilities program where we regulate the installation and operation of on-site sewage facilities within a zone around the Highland Lakes to help prevent wastewater pollution. For both of these regulatory programs, we partner and coordinate with other counties and other governmental entities across the Highland Lakes region in managing these programs, just kind of a note on that. And then in addition, there's the TCQ discharge ban, which limits the amount of direct discharge of wastewater within a 10-mile area of the watershed. These programs are really important. There's a lot of partner entities working together to protect water quality overall, for sure. But an area where there will always be more work to do is the education of private citizens living in the basin about how they can protect water quality, because we all play a part. We are all living in the basin. We all know now that everything that happens on the land can flow into the water, and we all have a part to play. So part of what this messaging looks like is it's really very simple. Maybe not easy, but it's simple. So big part of it, tying back into the nitrogen and phosphorus that I keep mentioning that we both monitor for and have an impact on the growth of algae, is reducing or eliminating use of fertilizers. Native plants don't really need fertilizers at all. And so we're really excited to kind of have this messaging out here to help you guys maybe have some talking points as you're working with the public or talking with neighbors or people in your community about what's the big why do we need to care about native plants. So, well, that's my goal, is that you'll have these talking points moving forward to really feel empowered to talk more about this. I will say, I think y'all can see me here, my little bitty rectangle. So OMRI certified products are basically like an organic certification for fertilizers. And there's a lot of different types out there. You know, I'm sure y'all are maybe even more well-versed in them than I am, but I use this Texas Earth product, and it's like little pellets. They also have a lot of beneficial microbes sometimes included with these OMRI certified products that both increase the nutrients in the soil, but in addition, the microbial diversity within that soil, because it all works together. The soil is a living creature. It needs support, it needs water, it needs all the things that any living organism needs. And so protecting that soil through the use of organic fertilizers over chemical fertilizers is always preferred for the soil health, but also for water quality. If you're using organic fertilizers, they tend to soak in slower. They're usually a part of a heavier organic matter material as opposed to these little tiny pellets that you buy for chemical fertilizers. And those tiny pellets are very easily washed into waterways. So that's, you know, if fertilization is certainly needed in some cases, but if you can, always, you know, we always recommend those organic OMRI certified products. So I belabored that bullet point a lot, and we'll talk, you know, a little bit more about that later on. Proper disposal of pet waste is a big one in these suburban areas and areas where there's a lot of dog owners, and certainly in off-leash areas. Lawn clippings or leaves from your property, you know, it's not the best idea to put those in storm drains or to let those go into the lake, because that is a source of nutrients for the algae and creates muck and organic matter that will stay in the bottom of the lake. So proper maintenance of septic systems certainly is important. And then what we're going to talk about the rest of the time we have here is the use of native plants along shorelines to filter and capture the rainwater runoff. And this is a big one. It's a simple step that provides multiple benefits. And we'll talk a little bit more about that now. So this is a picture that my uncle, Jack Latson, took. This is a chatterbox orchid. It's blooms from April to July, and to my knowledge is the only orchid in the Highland Lakes region. Y'all may correct me if I'm wrong there. So I want to talk about this other vocabulary word, riparian. Y'all may have heard of it, you may know what it is, but let's go over this. So you'll see in the schematic here, the rainfall is falling down to the surface. There's this grass filter strip that's capturing, slowing down some of that water, in addition to these forbs and shrubs and trees, slowing down that water on, you can see it's a sloped property. If there were no vegetation, that water would go fast. It would potentially erode the soil that is there, even if it was beautiful, organically fertilized soil. If there's nothing to keep it in place, like plant roots or the base of those really bushy native bunch grasses or something like that, then it's going to go into the lake or the storm drains or wherever, downhill is. So by producing or by having these plants on the property, they can slow down this water and then create all these other things in the kind of brown soil area that I've listed out here. The riparian area really begins, it's not like a specific line necessarily, but there's a change in the vegetation characteristics, and it has some unique soil properties. So typically these areas stay pretty wet, or at least the feet, the bottoms of the roots of the plants can touch the water typically. Or like in Texas, we'll have sections of creeks that go dry, but our native plants are adapted to be able to withstand these dry periods and then come back whenever there's water. So that's certainly a great value of these native plants in riparian areas. So to define a riparian area, it's just areas of land that occur along water courses and water bodies. So a little strip of land typically. They also kind of buffer against these higher flows, and riparian areas can be known as like flood zones or floodplains, where you see the sinuosity of rivers, and you can tell, that they've changed course over time. Well, that whole kind of section that you see from above can be defined as a riparian zone in general. So healthy functioning riparian areas may seem kind of unkept, overgrown, or shaggy. They're not really widely understood, and they're often underappreciated. People want this easy access to the water's edge, which understandably is helpful whenever there's, large gatherings or they want to just get to the water easily. And we'll kind of go over some alternatives to that as well. So riparian buffers can also be known as grow zones. And this is a picture of a creek in Austin, where the city of Austin has put up this sign to educate folks on a grow zone that they've created over the past decade, really, where they stopped mowing. They just let nature do its thing. And these trees have come up, and native grasses and shrubs that have really helped to protect these little urban creeks and provide some habitat that wasn't there, certainly. Some resources that y'all may already know of, but I just have to say if I'm going to talk anything about riparian plants in Texas, the Nueces River Authority. This is a just fantastic guide, and I encourage any of you who don't know about it to check it out. In addition, the Hill Country Alliance has this really great landowner's guide. It focuses on the Pedernales River Basin and more like riverside property riparian areas, but it certainly could apply to any area of the Hill Country. Even if you're a lakeshore property resident, this applies. It's more catered towards the creeks and rivers, but as mentioned, it can provide some helpful background information and education. So this, as you can imagine, is beautiful. It's not developed, but this is not what we would call a healthy, functioning riparian system. This has a lot of erosion potential. This has a lot of pollution potential. If a cow were to defecate on the edge here, there's nothing stopping that cow manure from going directly into the creek, which can then feed algae and decrease the biodiversity within that stream and degrade it. So in contrast, this is what we would consider a healthy riparian vegetation buffer. And this is, kind of an extreme where it's just super all natural. But you can see these bunch grasses. I think this is bushy blue stem, and got some willow in the background, it looks like. And if there is cow manure on the other end of this riparian buffer region, it's probably going to get filtered out and actually help these plants grow along the edge before even getting to the water, helping that water stay clean and clear and healthy for all of the critters and people that are using it. So this is kind of transitioning to some examples of what, the in-between, the healthy balance of both recreational access and riparian functioning, a functioning riparian buffer area. So if some of y'all may be familiar with, checking my time here, I'm almost done, Mike, for your purposes. And so what we have here is this little, you can see perhaps these steps going down to the river with some turf grass, or perhaps it's not turf grass, but just some shortcut native grasses. And then this really kind of robust riparian area. This is the sloped area down to the waterway, which is preferable because on sloped areas, you get more erosion potential, as you can imagine. And so in the Army Corps of Engineer lakes, a lot of these Army Corps lakes have regulations against certain development, and you can't really do anything within a certain area around from the lake property or the lake shoreline, ordinary high water mark, up to a certain buffer region, and that's to protect water quality. So we don't have that on the Highland Lakes, and so providing this information on voluntary measures that people can do, best management practices, is really pretty crucial. We're already built up a lot around the Highland Lakes, but there's so many things that people can do retroactively to help protect water quality and create these little buffer strips, even if they're bulkheads, even if there's not a natural shoreline. Here's another example. This is again from the Hill Country Alliance, showing, I think this is certainly a picture on the Pernalis, variety of things kind of checked off here, where you get the access to the waterway with this, soft turf grass down where you can be barefoot, and a healthy functioning riparian buffer zone there. Another example here. This is a lake shoreline, and it certainly has a lot of access points, maybe a lot of high traffic use, and the turf grass was preferable. But you can see, there's a lot of erosion potential here too, with wave action, rainfall coming from the property and going into the lake, and just a whole lot of pollution potential as well. Some alternatives to just that straight turf grass up to the water's edge are little gardens like this. And this is not from our basin. I found this on the internet and I just really liked it because they kind of kept the bottom part of their property that touches the lakeshore line, as open, so that they can run in and out of the water at lots of points. If they have lots of grandkids, they can go in and out and it's no problem who's fighting over the access to the water. But above that, they have this kind of neat little terrace where, as these plants grow, it provides that, diversity and ability to slow down the water, soak it in, help those plants grow, and provide a lot of benefit. I'm sure you've all probably heard of rain gardens. These have many benefits. This is a school in Austin. I think this is Riley Elementary School. Pretty easy, honestly, to implement and retroactively place in a location. And I will say, as the Hill Country continues to grow, development is not slowing down. We really can advocate for development that's smart and that produces the opportunities for better water quality protection on the small scale. So rain gardens, even rainwater harvesting is certainly something that is, you know, challenging in some ways to install. That's a more of like a typically a landowner's choice, right, on their individual properties. But even on these large scale, like new schools being built or municipal buildings, there's opportunities there for rainwater catchment. And I'm not an expert on this, but I thought it was worth mentioning in this presentation. These all kind of work together to help keep water, slow it down, keep water on a property as opposed to letting it flow off into a creek, which has both water conservation and water quality benefits. And I really liked this slide because a lot of Austin, so this is from Austin, a lot of Austin was built up without water quality best management practices in mind. And this is a curb cut that they created. You can see kind of the newer concrete there to allow that water from the street to go into these little teeny basins and slow down. I would say an added improvement to this would be to put some plants that could withstand kind of this drying, wetting that occurs in this area and make it more aesthetically pleasing. But this is a step in the right direction. And as the country is built out, you know, I would certainly encourage folks to speak up on opportunities for little things like this that could be put in place and not have to be like retroactively installed like we're needing to do in Austin. You know, in the last few slides here, I just want to kind of highlight some of these plants that can be used in riparian areas. And this came from the Lady Bird Johnson Wildflower Center list. Is actually something I got from Parks and Wildlife, and I think originally from the Wildflower Center, but just a tremendous amount of diversity of different plants that could be used in riparian areas that have a variety of benefits. So if y'all aren't familiar with the wetland indicator status, the OBL stands for obligate wetland plants that are almost always found in very wet locations. They're not really great at kind of the drying out spells as much. Then there's the facultative wetland plants, or the FACW. They're usually found in wet locations. Then FAC, facultative plants found equally in wet and non-wet locations. FACU, facultative upland plants usually found in non-wet locations, so uplands being kind of above that riparian area. And then UPL being these obligate upland plants that don't really like their feet wet necessarily all the time. Here's some trees and shrubs. Again, just kind of a little touching base on some of these species that are probably very familiar to many of you. I know there's a variety of places to get these. I know you guys have done plant sales as well as the Wildflower Center. There's, you know, a grower in Cedar Creek, McNeil Growers, Madrone Nursery in San Marcos. There's a lot of great places to get these plants these days. And then finally, some forbs and shrubs. And really a note on this too is kind of the beauty and aesthetic value that is so important. As we all know, nature has been an important aspect of us during COVID times and not being able to see our people. But so this aesthetic value, I think, is certainly something to highlight, because we all need the connection to nature, the connection to beauty around us. But the bonus is that this is a multifunctional thing here. When we have these riparian areas full of native plants, we're providing habitat, we're providing water conservation, we're increasing the soil moisture on our property, reducing erosion potential on that land, and helping water quality, diminishing the issues like harmful algae that are occurring and will still kind of pop up from time to time, certainly. But the more we do individually and the more we spread this message of water quality protection using plants and other means, the better off we are. And the better off we all are, I should say. So this is just a small sample of some of the photos that my uncle took. So this is from top left to bottom right. This is seep willow, lance leaf water willow, swamp dogwood, yellow flag, aquatic milkweed, spiderwort, wild plum, and pickerel weed. These are all some plants that grow in kind of wetted soils in riparian areas. So that really concludes my presentation, and I'm a little bit over on time, but very happy to answer any questions that you have. I know I covered a lot of topics here, but yeah, happy to answer any questions, and thank you so much.
Very good. Thank you so much, Lisa. That was really helpful to understand what our challenges are and what we can do about it. We have a few minutes. I wanted to share a couple questions. You were talking about algae being a real challenge for dogs potentially. What about people that like to drink lake water while they're swimming?
Well, we would never encourage people to drink lake water. I know certainly most people don't.
Grandkids that love to do that.
Yeah, grandkids, yeah. So the issue with harmful algae and really bacteria or any increased risk in a natural body of water comes from ingestion primarily. So that's why we're kind of cautioning folks to really keep their dogs out of the water if they see algae, because these little bitty pieces of algae could be floating around in the water. And so if there are small grandkids, certainly have two young girls, I know how that goes. I would educate them on the fact that it's really important not to get water in their mouths. I'd say in any water body, honestly. There's giardia, there's all kinds of stuff. Just, I know too much, certainly, but yeah, there's an education curve there. No one needs to be putting lake water in their mouth if they can avoid it. But I will say, avoiding algae is the message, because the toxins are in the algae, and also debris or algae in the water can harbor bacteria and other microorganisms that could also not be great to ingest.
Thanks. Another question regarding why is that phosphates, phosphorus, is not measured as much as nitrogen?
Oh, that's a great question. I'm glad someone asked that, because they actually are. Nitrate nitrogen is what we use for the Crown program, because there's a test that's easier to use than the phosphorus test for these quick tests for volunteers. But as part of our Clean Rivers program, we certainly monitor phosphorus, and it's usually the most limiting component, I should say, to algal growth in the aquatic ecosystem. And I think that's true for typically the upland ecosystems as well, and the land terrestrial ecosystems, is that phosphorus is typically the most limited. So when you add phosphorus, you get more production of algae and more plant growth in general.
I think we have time for one more question. Regarding nitrogen or high concentrations of nitrogen in the lakes, is algae the main negative impact, or are there other things that happen in the water that we need to be concerned about?
So in regards to the
nitrogen
pollutants
going into the lakes.
Yeah, so nitrogen it's kind of got a complex cycle. And the most readily found form of nitrogen is called nitrate nitrogen. And nitrates are certainly not good to have in drinking water. It's something that's regulated and measured by all drinking water facilities. Nitrates, if they're in a high amount within drinking water, they can kind of interact with the blood's ability to carry oxygen. And so it's certainly something from a drinking water standpoint that's monitored, but also because of algae growth. So the more fertilizer, the more growth of algae, and the more muck that can accumulate in a lake. I hope that answers the question.
Yes. Well, thanks so much. This was such a big help in understanding where we need to go and how to do that. And I wanted to mention that for anybody that is not familiar with how to get information regarding native plants, the Native Plant Society of Texas website under resources and education have several options. And you can just pull the tab down and it'll give you ideas about where you can find native plant purchases or native plant advice throughout Central Texas.